Okay, in today's lesson, we're going to be solving exponential equations using a common base. Now, later on, we'll be solving these exact same type using logarithms that we can't solve using these common bases. So here's our steps. Step number one, we're going to rewrite the equations using a common base. And a reminder that anytime you're dealing with an exponent, the number being raised to a power is the base. So we're going to try to be getting like bases here. We're going to use our properties of exponents, step number two, to simplify each side of the equation. Step number three, we're going to use the one-to-one property that says if b to the x power is equal to b to the y power. Well, the only way that that could be true is if the exponents are the same. And then finally, we're going to solve. Okay, set number one. Let's solve some of these. And the first ones start out pretty simple. They've already got those common bases. You have 3 to a power equals 3 to a power. So let's use that one-to-one principle. And we know that the only way that this could be true is if the powers are the same. So therefore, simply set the powers equal to each other, move the 9 over by adding, divide by 2, and you get x is equal to 8, and that's it. Number 2, e to a power equals e to the power. The only way that that, again, can be true is if the powers are equal to each other. Let's move all of our w's to one side. Let's move minus 2 by adding 2w. Now we now have 6w. Move the minus 1 by adding 1. We now have equals 6. So therefore, w would equal 1. Number 3. Here we do have to use our rules of exponents. We have 5 to a power times 5 to a power. Before you can use this principle, you have to combine these. Rules of exponents says if you want to multiply, if you have like bases, all you have to do is take these two powers and add them. 5 squared and 5 to the third would be 5 to the fifth. So therefore, 5 to the c minus 1 times 5 to the 3c plus 2 would be 5 to the, let's add our c's, would be 4c. And negative 1 and positive 2 would be plus 1. Is equal to 5 to the 7c plus 16. Now it's done the exact same way. 5 to a power equals 5 to a power. The only way that can be true, one-to-one rule, is if the powers are the same. So equals 7c plus 16. Let's move our 4c's by subtracting. We now have 3c's. Move your plus 16 by subtracting. 1 minus 16 is a negative 15. Divide by 3 and you get c is negative 5. Number 4, same thing, except for we're going to use our product rule on both sides. We're multiplying like bases, so we're going to add our exponents. On the left side, we're going to have 8 to the, let's combine like term, k squared. We're going to combine 1k and 2k, and that'd be plus 3k. And then a minus 9. Again, we just added our exponents. And on the other side, we have 8 to the 4k plus 11. And again, now the only way this could be true is if the powers are equal to each other. So let's set our powers equal to each other. We have a quadratic equation because of the k squared, so let's move everything to one side. So let's subtract our 4k and let's subtract our 11. So we now have k squared minus 1k minus 20 is equal to 0. Best way to solve these are by factoring. So two sets of parentheses. K times itself gives me k squared. Adds, multiplies would be a negative 5 and a positive 4. So therefore, my solutions would be k is equal to either a positive 5 or k is equal to a negative 4. Okay, now starting with number 5, we're going to see that we don't have that common base. Set number 2, without a common base. Notice here we have a 9 to a power and an 81. Those bases are different. So what we're going to do, we're going to rewrite these to make them have the same bases. So we could do 9 raised to the 4y minus 26 power is equal to 81 is the same thing as 9 to the second power. So therefore now I can change these. The bases are the same. So now I can do the exact same thing. Set the powers equal to each other. Move the 26 over by adding, and we get 4y is 28. So y must be 7. And you can check that. You can plug that in, and you get 4 times 7 is 28 minus 6 is 2. So 9 to the second power does, in fact, equal 81. Next one, 64. These numbers are both base 4 numbers. We can write them with a base of 4. So 64, I know 4 times 4 times 4 is 64, but we need a 1 over 64, so we're going to do 4 to the negative 3 power, because once again, to make a negative exponent positive would bring it to the bottom of a fraction. So 1 over 64 is 4 to the negative 3. That's equal to 4 to the a squared minus 4 power. Since the bases are now the same, we can set the exponents equal to each other. And notice here, this is quadratic, but you're missing your b term. There's no plane a. We only have a squared, so we can solve this by taking the square root. Let's move our minus 4 over by adding 4, and we get a squared is 1. And to get rid of a squared, we're going to do plus and minus the square root of 1, which is 1. So we have two different answers there. Number 7. 2 and 32, we can change both of these to a base 2. 2 is already there, so 2 to the m minus 9. 32 is actually 2 to the 5th power. So here's what we're going to do here. You have 32, which is 2 to the 5th, and that is being raised to the m plus 3 power. A power to power, now what we're going to do is we're going to multiply those powers. And you got to be careful, because if you don't distribute here, you're going to miss this problem. So you have 2 to the 5th to the m plus 3. You got to do 5 times m plus 3, which would be 5m plus 15. Multiply them both by 5. So now set the powers equal to each other, solve it, and we're finished. 5m plus 15. Let's move our m by subtracting. We now have 4m. And if we're going to put our m's on that side, move your 15 by subtracting, and you have equals negative 24. So therefore, m would be negative 6. Next up, number 8. All of these are actually, looks like nearly already base 12 numbers. The only thing we're going to have to change is 1/12. We're going to have to write as 12 to the negative 1 power. And that's raised to the 4x plus 3. Times 12 to the x squared equals 12 to the 2x plus 13. Plus 13. Powers to powers, here we're going to have to multiply those powers. Make sure we distribute when we do. That would be 12 to the negative 4x minus 3 times 12 to the x squared equals 12 to the 2x plus 13. To combine these, we're going to have to add our exponents. So we now have 12, no like terms there, so we can just write it in descending order. X squared minus 4x minus 3 equals 12 to the 2x plus 13. Now, since the bases are the same, we have 12 to a power equals 12 to a power. We can now just set the powers equal to each other. Equals 2x plus 13. Let's move our 2x by subtracting 2x and move our plus 13 by subtracting 13. And I now have x squared minus 6x and a minus 16. Two sets of parentheses. X times itself gives you x squared, adds, multiplies is a negative 8 and a positive 2. So therefore, x is either equal to 8 or x is equal to negative 2. Okay, more of the same. Number 9. 343 and 49. Now this one's a little bit trickier. We've got to find something that we can turn both of these into the same base. And we already know 49. That's pretty simple. That's 7 times 7. So let's try to raise them both to a base of 7. And that will work, because 343 over here, that is 7 to the 3rd power. So we're going to write this as 7 to the 3rd to the 2n minus 4 equals 1 over 49 is 7 to the negative 2. We're going to raise that to the n plus 4 power. Power to power, let's multiply them. Don't forget to distribute. That'd be 6n minus 12 equals 7 to the negative 2n minus 8. Let's now set them the powers equal to each other. 6n minus 12 is negative 2n minus 8. All the n's go to the same side. Let's add 2 n's. That gives me 8 n's. Let's add 12. That gives me is equal to 4. Divide by 8. N is 4 divided by 8. That won't divide without giving us a decimal, so let's just reduce it, and we're going to get 1/2. Again, if you had divided it, you would have got 0.5 there. Next up, 8 and 128. I know that 8 we can turn into a base of 2, and that's about it. You could either leave it as 8 or turn it into a 2. So let's try them both as a base 2. So 8 is 2 times 2 times 2. And that's raised to the 2 minus v power. 128, that would be 2 to the 7th power, and that's raised to the v plus 3. So now powers to powers, let's multiply. That's 2 to the 6 minus 3v, and this would now be 2 to the 7v plus 21. Again, distribute. Set your powers equal to each other. 6 minus 3v is 7v plus 21. all the v's to the same side, so let's add 3 v's. That gives me 10 v's, so let's subtract 21, gives me a negative 15. We now divide by 10. That's going to be a decimal, so instead of dividing, let's reduce it. Divide top and bottom by 5, and it gives you a negative 3 halves. Number 11. 9 is a base 3 number, so we're going to write it as 3 squared to the negative p. Equals 243 is 3 to the 5th power to the 2p plus 6. Powers to powers, let's multiply 2 times negative p, that'd be negative 2p. And over here, let's distribute 5 times everything would be a 10p plus 30. Powers are now set equal to each other. Negative 2p is 10p plus 30. Let's move our 10p just because then our 30 will be isolated by subtracting. That'd be negative 12p is 30. Divide by negative 12, and you get p is equal to a negative, because positive divided by negative. Divide by 6 to reduce it. That'd be a 5 halves. Number 12. 4 and 64. And again, we have fractions, so I know these are going to be negative exponents. I know that actually 4 to the 3rd power is 64, so I could leave this as a base 4. That'd be 4 to the negative 1 to the 2x squared minus 6 equals, like I said, 4 to the 3rd is 64, so this would be 4 to the negative 3 power to bring it to the bottom to the 2x squared minus 5. Powers to powers, let's multiply, so that's going to be 4 to the negative 2x squared plus 6 equals 4 to the negative 6x squared plus 15. Now I can set the powers equal to each other. Negative 2x squared plus 6 equals negative 6x squared plus 15. I do want to point out that there's no x term. There's only x squared term, so we can solve this one by simply taking a square root. Let's put all of our x squareds together. Add your 6x squared, you now have 4x squared. Subtract your 6, you now have equals 9. Get rid of the 4 by dividing, so x squared is equal to 9 fourths. So therefore, x will equal plus and minus the square root of 9 fourths, which would be a plus and minus to square root a fraction, square at the top and square at the bottom, and you're finished. Number 13. All of these, let's see, 36 to a power will not give you 216, so we're going to have to write all 3 of these terms as base 6 numbers. So 36 is 6 squared, and that's to the 2r, times 1 over 36 is actually 6 to the negative 2 power, and that's nothing's been done to that. And then 216 is 6 to the 3rd power. Powers to powers, we're going to multiply. You do not have to distribute because there's no plus or minus signs there. That'd be 6 to the 4r times 6 to the negative 2 equals 6 to the 3rd. To multiply two exponents, you actually have to add the exponents. So that'd be 6 to the 4r minus 2. And you might be saying, well, you subtracted those. No, we did it 4r plus negative 2, which we can write as 4r minus 2, equals 6 to the 3rd. Set the exponents equal. 4r minus 2 is 3. Let's add our 2. That's 4r is equal to 5. Divide by 4, and you get r is equal to 5 fourths. Number 14. 25, 625, and 1 over 25. 25 is a base 5 number, so we can write it as 5 squared raised to the a. 625 would be 5 times 5 is 25 times 5 is 125. That'd be 5 to the 4th power to the a plus 3 power equals 1 over 25 would be 5 to the negative 2 power. So now let's do our powers to powers. That'd be 5 to the 2a times 5 to the 4a plus 12 equals 5 to the negative 2. To multiply like bases, we're going to add our exponents. That'd be 5 to the 6a plus 12 equals 5 to the negative 2. Now that the bases are the same, let's set our exponents equal to each other. 6a plus 12 is negative 2. Move your plus 12 by subtracting, gives you 6a is negative 14. Move your 6 by dividing, so a would equal, we can't divide that, so let's just reduce it, negative 7/3. Number 15. You have 16, 64, and 32. All of those, these two are actually base 4 numbers. We could write this as 4 squared and 4 to the third. However, this is not 4 to a power. So we're going to have to go even further down and write them as base 2 numbers. I know that 16 is 2 to the fourth, and you can check that. So therefore, 1 over 16 would be 2 to the negative 4. And that's being raised to the x plus 7. Times 64, that's 2 to the 6th power, and that's being raised to the x plus 5. Equals 1 over 32. I know that 2 to the 5th is 32, so 1 over 32 would be 2 to the negative 5th power, and that's being raised to the 4th. So next up, powers to powers, let's multiply. This would be 2 to the negative 4x minus 28 times 2 to the 6x plus 30 equals 2 to the negative 20. Like basis, let's add our exponents. Negative 4x, we're just combining like terms. Negative 4x plus 6x gives me 2x. Negative 28 plus 30 gives me a positive 2 is equal to 2 to the negative 20. Exponents are now equal to each other. 2x plus 20 is negative 20. Subtract 20 gives you 2x is negative 40. So therefore, x has to be negative 20. And the last one. 5, 12, 64, and 8. And you can check this to see if 5, 12 is a multiple of 8. And if you did 8 times 8, you get 64, which gives you both of these. And then 64 times 8 again is actually 512. So therefore, 512 is 8 to the third, and that's being raised to the y squared power. 64, 8 squared is 64, so 8 to the negative 2 would be 1 over 64. And then 8 to the negative 1 would be 1 over 8. Powers to powers, let's multiply. This would be 8 to the 3y squared equals 8 to the negative 6y times 8 to the negative 5y squared. Let's combine these two by adding our exponents. 8 to the 3y squared equals, you can't combine those, so therefore let's just leave it as negative 5y squared minus 6y. I just wrote my y squared stuff first. Now our bases are the same, so let's set our exponents equal to each other. Negative 5y squared minus 6y. Move all of your y squared to the same side. Actually, you have y squareds and y, so let's move everything to the same side. Add 5y squared gives you 8y squared. Move minus 6y by doing plus 6y. Now it's equal to nothing on the other side. The reason I did that is because it is missing a c term. We can't do the square root of both sides because of the b term being there, but we can move everything to the same side and simply factor out the y is one method, or you could factor out a 2y if you wanted to. So let's do that. Factor a 2y out. You're left with a 4y here, and you're left with a plus 3 here. Set each factor equal to 0. 2y is 0, 4y plus 3 is 0. Divide by 2 gives you y equals 0. Or subtract 3 and divide by 4 gives you y equals negative 3 fourths. There's your two answers.